Hey guys, this is the work for questions 24 through 34 of our Algebra 1 readiness packet. So for number 24, it says which of the following must always be true if x, y, and z are negative rational numbers. A rational number is basically any number that can be written as a fraction or a decimal with a repeating pattern. A rational number could also be any whole number, such as 1, 2, and 3. So because I don't know what x, y, and z are, and I look at my options, I'm going to start just testing numbers and see what happens. So all we know about x, y, and z is that they're negative and they're rational. So let's say that x is equal to -1, y is equal to -2, and z is equal to -3. Now this is just to test out which one of these is true. If I multiply a negative with a negative and another negative, when you multiply two negatives together, it gives us a positive, and we multiply with another negative, that gives us a negative answer. So x times y times z is never positive, it's always negative. And if you look at option D, that's exactly what it says. X times y times z is negative, since multiplying three negatives together gives us a negative answer. For number 25, a cube has a volume of 216 cubic inches. What is the edge length of the cube? So a cube is a box, right? And in order to find the volume of any box, that is going to be the length times the width times the height. Now because a cube, has all equal sides, since everything is a square, then the length is going to equal the width, which is going to equal to the height. So I'm just going to call that x. So this is my length, this is my width, and this is my height. If I multiply x times x times x, since length is x, width is x, h is x, that would give me x to the third power. And we are told in the question that the volume is equal to 216. Now, to get rid of an exponent, we would have to apply the appropriate radical. You know how if we had x squared is equal to 25, we would apply the square root, and we get that x is equal to 5. With an exponent of 3, we still do a radical, but it would be the third root of 216. So that means here we get 25 because 25 is 5 times 5. That's a pair. It's the two identical numbers that would give us the 25. But now here with the radical with this little 3 there, that means I need three identical numbers that multiply to give you 216. So let's break this down. 216 can be broken down to 6 and 36. Since 36 times 6, if I multiply that, this is 18 plus 3 gives me 216. But these are not the same number, so we have to break them down again. 36 is 6 times 6. These are my three identical numbers. So the cube root of 216 is equal to 6. So that is the edge length. This is an edge. So that's going to equal to 6. Let's go to number 26. The numbers of blue and green beads Emma uses to make 5 different pieces of jewelry are recorded below. Which of the following equations relates the number of green beads, G, to the number of blue beads, B? When you see this, relates, that's usually some type of a ratio. The number of green beads over the number of blue beads, G to B, G to B. This is a ratio. So ratios can be written this way. In this case, G to B, or G colon B, that means the same thing, or as a fraction, G to B. So ratios are written like that. Now, if I look at my table, For every 4 blue beads, we use 7 green beads. For every 8 blue beads, we use 14 blue beads, etc. If you look at how it's increasing, the green beads is always going up by 7, and the blue beads are always going up by 4. So green is this one here, is 7 over the number of blue beads, which is 4. Now if I look at my options, the only one that, first of all, we have 7 over 4 here. So I can eliminate A and D because that's the ratio that we're looking for. Now it says relates G to B. So we want the equation to read G equals, because that's the relationship they're looking for. A ratio like this, which is a fraction, just means division. So if I want to move this B over to the other side, the opposite of division would be multiplication. So I would multiply B to both sides. So G would equal to 7 over 4 B, which is C. For 27, what is 0.53 repeating, that's what the little bar means, as a fraction? So this is how you would do it. We're going to write 2 equations. We have 0.53 and then it repeats. So I'm just going to repeat the 3's. The first step is to move this decimal point over until you get past the repeating number. So I just moved it over 2 times. So that means I'm going to take 2. I moved it 2 times, right? So that's 100 times x. X is going to represent the fraction that we are looking for. Now we're going to take the same number, 0.53333, and move the decimal over just before the repeating number. I only moved the decimal over once, so that would be 10x. So however many times you move the decimal over, that's how many zeros you're going to have before you put the x. Now what we do is we subtract. So we have 53.3333 minus 5.3333. So all of these repeating 3's, when I subtract them, would cancel out. So we're going to do 53 minus 5, which is 48. And that's going to equal to 100x minus 10x, which is 90x. This is starting to look a little better. To solve for my fraction, we're going to divide by 90 to the other side. So x is going to equal to 48 over 90, which is not an option here, so we have to simplify that. 48 and 90 are both even numbers, so we can divide each of those numbers by 2. 48 divided by 2 is 24, and 90 divided by 2 is 45. This is still not one of these options, so we have to simplify this again. 24 and 45 are both not even numbers, so let's try and see what happens if we divide by 3 instead. 24 divided by 3 is 8. And 45 divided by 3 is 15. So my answer here would be C. For number 28, it says the perimeter of a rectangle is 42 feet. The length of the rectangle is 12 feet. What is the width of the rectangle? So let's draw out our rectangle. This is a length, this is the length, width, and width. It tells me that the length of the rectangle is 12. And the perimeter is 42. To find the perimeter of any shape, we would add all of the sides together. So we have L plus W, length plus width, plus another length, plus another width. And it tells me in the problem that this is going to equal to 42. Now we are given that the length is 12. So I'm going to replace the L's with 12. So we have 12 plus W plus 12 plus W is equal to 42. Now let's combine like terms on this left side. We have 12 plus 12, which is 24. Then W plus W, there's two W's, so 2W equals 42. Now, let's solve for W. We're going to subtract the 24 to both sides. And this will give me 2W is going to equal to, this I need to borrow a 1 from the 4. 12 minus 4 is 8. And then, oops, this is a 3. 3 minus 2 is 1. Then we divide the 2. So the width of the rectangle is going to be 9. Now this one says a food truck sells sandwiches and drinks. One customer bought 4 sandwiches and 6 drinks for $30. Another customer bought 3 sandwiches and 3 drinks for $19.50. How much will a customer pay for 5 sandwiches and 4 drinks? So let's try this out. For this first customer, 4 sandwiches and 6 drinks are $30. I don't know the price of either sandwiches or drinks, so I'm going to write some equations. I'm going to let S equal the price for sandwiches, and D is going to be the price for drinks. For this first customer, 4 sandwiches, 4 times S, whatever the cost is for one sandwich, plus 6 drinks is going to equal to 30. For the other one, the other customer bought 3 sandwiches plus 3 drinks for a total of $19.50. For me to figure out how much a customer will pay for 5 sandwiches and 4 drinks, I need to figure out the cost of 1 sandwich and 1 drink. In order to do that, we need to solve this system. There are 2 ways to solve for a system. Either you use substitution or elimination. Substitution is useful and easier for some types of problems, but elimination works every single time. And elimination is exactly what it sounds like. We're going to eliminate one of these variables. Now you can choose any of the variables to eliminate. We can eliminate the S first, or we can eliminate the D first. That is up to you. And how you eliminate is that you want to either multiply one or both of the equations by a number that will allow those variables to cancel. So for example, if I wanted to cancel the S's, I would multiply the top equation by 3, the bottom equation by 4, make one of those negative, and you would have 12s and negative 12s that would cancel. However, with the 6D and 3D, if I multiply the bottom equation by negative 2, 3 times negative 2 is negative 6, which will cancel out the D. So that's what I'm going to do. So I don't have to multiply both equations. I'm only going to multiply the 1. So the top one is not going to change. 4S times 6D is equal to 30. Now when I multiply negative 2 to the bottom equation, I get negative 6S minus 6D is going to equal to, let's do the 19.5 times 2. This is 0. This is 18, plus 1, so 9. And 3, 1 decimal point, so 39. Negative 39, because the 2 is negative. Now we add the equations together. 4S minus 6S is negative 2S. 6D minus 6D, see, they cancel out. We get 0D. And that's going to equal to 30 minus 39, which is negative 9. Finally, we divide by -2. So let's do 9 divided by 2. 2 goes into 9 4 times to give us 8. 9 minus 8 is 1. We don't want a remainder because this represents a price. So I'm going to put a decimal here and bring down the 0. 2 goes into 10 5 times with no remainder. So that is what S is equal to. A negative divided by negative makes it a positive. So the price of one sandwich is $4.50. To figure out the cost of the drink, once you have one variable, you take any of the original equations and you plug it in. So let's plug it into the top equation. You could also plug it into the bottom equation. It does not matter which one. So I'm going to plug it into the top. 4 times 450 plus 60 is equal to 30. So let's do the 4 times 450. This gives me 0, this is 20, this is 16, plus 2 is 18. 2 decimal points, so $18 exactly. Plus 60 is equal to 30. Now we subtract the 18. 60 is equal to 12, and then divide the 6. So D is equal to $2 exactly. So now I have the cost of each one. So finally, we can find what a customer would pay for 5 sandwiches and 4 drinks. We're going to do 5 times the cost of each sandwich, which is $4.50, plus 4 times the cost of a drink, which is 2. Let's do the 5 times 450. This is 0, this is 25, this is 20 plus 2, so $22.50. And we have 2 decimal places, so $22.50 plus 8, which is equal to $30.50. Let's go on to 30. And if at any point in time you need time to work this out on your own, you can always pause the video, work, and then check your answer. This one reads, the following dot plots describe the test scores on Mr. Santos' final exam. Which statement is a valid inference based on the means of the data sets? Just so you understand, a mean is an average. And how we find an average is by adding all of the numbers up and dividing it by however many numbers you have. Now, how to read these dot plots? The first one is for his second period class. And what this reads is that one person got a score of 55. Another person got a score of 70. 6 people got a score of 80, 75 and 80. 2 people got a score of 85, like that. You don't necessarily need to calculate the average to know more or less where the average is going to be. Look for where the majority of your dots are. The majority of the dots are here for the second period class, in between 75 and 80. So that means that the average is going to be somewhere in here. Also, this number here, this is an outlier. The farther away your outlier, the more it's going to affect the average. Since this is a low outlier, because it's on the low end, that means that the average will be even lower. In the 6th period class, the majority of the dots are here at the 85. So this average is a little bit higher. Plus, this outlier is higher than this outlier. What that means is that this outlier will affect this average. It will lower it, but not as much as this one because it's not as low as this 55. So let's look at these options. From here, just by looking at these boxes, I can tell that this class here overall did better because the average is higher. the closer on the right your dots are, the larger the average will be. The second period class scored higher than the sixth period class. We just said that the second period class did lower than the sixth period. So this is no. The mean of the sixth period class is less than 80. So mean, remember, mean means average. Of the sixth period class, it's not going to be 80 because the majority is at 85. So that means it'll be closer to this end. The classes scored the same. Clearly they did not. The sixth period did better. So final answer, the sixth period class scored higher, which that's the one that would be our answer. Now let's look at 31. On a map, 1 inch equals 450 miles. Two cities are 635 miles apart. Approximately how far apart are the cities on the map? So this is what's called a scale. And a scale is basically relating one measurement with another. And listen to my words, relating. This is a ratio. And the ratio is inches to miles. So I can write this as a fraction, inches over miles. We are told here that 1 inch equals to 450 miles. So I'm going to use my measurements here so I know where to put these numbers. 1 inch for every 450 miles. Then here it says two cities are 635 miles apart. So this 635 has to go down here because that's where the miles go. Approximately how far apart are the cities on the map? That means that we're looking for the inches. I don't know what that is, so I'm going to call that x. So this is an equation that I need to solve. If you have where one fraction is equal to another fraction, what we do is we cross multiply. 1 times 635 is 635. And that's going to equal to 450 times x, which is 450x. To solve for x, which is my inches, I'm going to divide by 450. So let's do that. We have 635 divided by 450. 450 goes into 635 only one time, because double will be 900, so that's too much. So this is 450. We subtract. This will be 5. I'm going to need to borrow 1 here. 13 minus 5 is 8, and 5 minus 1 is 1. 5 minus 4 is 1. Now, 450 does not go into 185, so I'm going to put a decimal here. And I'm going to bring down a 0. Now look what happens. I'm looking at my options here. My answer is going to be 1 point something, so it can't be A or D. Let's see which one it is. I have here it's either 1.4 or 1.5. So let's try 4. 4 times 0 is 0. 4 times 5 is 20. I'm going to carry a 2. 4 times 4 is 16, plus 2 is 18. So this leaves me with the remainder of 50, which we can continue dividing, but already I see it's 1.4. Next one, which of the following are not possible values for m and n? If we look here, we have two terms where the bases are the same. They're both 9 and 9. And then you have these exponents, m and n. Whenever you have two terms, I'm going to make up an example here. Let's say x to the 4th over x squared. What we do is we take the exponents, because these are like bases, and we subtract. So this would equal to x raised to the 4 minus 2, which 4 minus 2 is 2. So that's how that works. So that means that this is 9. I'm going to subtract my exponents, so always the top minus the bottom. M minus n should equal to what it gives you here, 9 raised to the negative 5. So this here has to equal to this here. So m minus n has to equal to negative 5. Here they give you different values for m and n, and we have to check which one of these do not subtract to give you negative 5. For this first one, m is 8, n is 13. 8 minus 13 is negative 5, so it can't be this one. Negative 2 minus 3 is also negative 5, so it can't be that one. Negative 9 minus 4 is equal to negative 13. This is not negative 5, and that's what the question is asking, which of the following are not possible values. So C. Let's go on to 33. One weekend, 152 people attended an art exhibit. The following weekend, 298 people attended. To the nearest percent, what was the percent increase in number of people attending the exhibit? To figure out a percent change, we would get the new number, the one that changed, and subtract it from the old number, the original, and then divide it by the old number, followed by multiplying it with 100 to give you a percent. The original number was 152 people. That's your old number. The new number is 298 people. So now that I know what is my old and what is my new, I'm going to plug it in here. So 298 minus 152 divided by 152 times 100 is going to give me that percent change. Let's do 298 minus 152. 8 minus 2 is 6, 9 minus 5 is 4, and 2 minus 1 is 1. So up here is 146 divided by 152 times 100. So let's do this division. 146 divided by 152. Now 152 does not go into 146. So I'm going to put a decimal and add a 0. And now I'm going to do 152 inside of 1,460 instead of 146. This is about 9 times. 9 times 2 is 18. 9 times 5 is 45. Add 1, so 46. 9 times 1 is 9, plus 4 is 13. So now let's subtract. I'm going to have to borrow 1 from the 6. 10 minus 8 is 2. I'm going to have to borrow another 1 here from the 4. 15 minus 15 minus 6 is 9. 3 minus 3 is 0, 0. So now 152 into 92, it's not going to work. So let's add another 0. 152 goes into 920. Not quite sure, but let's try 6. And the reason I'm trying 6 is because I see here that all of the percentages, you have 32, 50, 51, and then 96. I already got the 9. So it's most likely this one. But let's double check. So 6 times 2 is 12. 6 times 5 is 30, plus 1, 31. And then this will be 9. And we end up with a remainder of 8. But I don't need to keep going because this is my percent. It's approximately 96% because 0.96 times 100 means I'm going to move the decimal over twice. So that is my 96%. Last one here. How many solutions does the equation have? If we're trying to figure out solutions, let's just try to solve it and see if we get an answer. And let's see what happens. Now I know that we have some fractions on here. So if you ever want to get rid of a fraction, look at the denominators. These are all 4. So if I take the entire equation and multiply by 4, what's going to end up happening is I'm going to cancel out those fractions. So let's do that. So remember, I'm multiplying the entire thing because you can't just multiply a number to a piece of the equation. You have to multiply it to the entire equation. So 4 times 2 is 8, plus 3 over 4x times 4. Let me show you what's going to happen here. When you're multiplying, I'm writing it as a fraction, so you can see what happens when you multiply fractions. You multiply numerator with numerator, denominator with denominator. 3 times 4 is 12, and 4 times 1 is 4. And of course we have the x. And 12 divided by 4 is 3x. Another trick is if you ever have fractions that you're multiplying and the diagonal is the same number, they cancel. And see, we're left with 3 over 1, which is 3. So that 3 over 4x times 4 is 3x. Now let's continue. Minus 5 times 4, 20. And that's going to equal to 4 times 3x, which is 12x, minus 4 times 3, which is 12, minus 9 over 4x times 4. Same deal. The 4's are diagonally across, so they can cancel. So we're left with 9 over 1, which is 9, and of course the x. Now, let's combine like terms on either side. We have 8 minus 20 that we can combine. So that's negative 12. Then the 3x is going to equal to, now we have 12x minus 9x, which is 3x, and then minus 12. If we continue to solve, right, I want to solve for x. So I'm going to add this 12 over to the other side so I can cancel it out. And now I'm left with 3x is equal to 3x. Not much is going on here. If I'm trying to get the x's all on one side, I would subtract this 3x over to the other side, and we end up with everything canceling. 0 equals 0, which this is true. If you ever end up where the variables cancel out and you're left with what's called a true statement, like 0 equals 0, or 5 equals 5, or 1 equals 1, these are all true, that means that there are infinite solutions. However, if you're solving an equation where the variables cancel and you're left with a false statement, like 4 equals 1, 4 does not equal to 1. This is a false statement. This would mean that there is no solution. So that's 24 through 34. And don't forget to submit your work.